Hello students. So in this short video, I'm going to go over two examples of graphing an ellipse centered at the origin. So let's begin. Let's graph this ellipse, identify the center, vertices, and foci of the ellipse. First of all, the center is HK, which is 0, 0. So we're going to put the center. Next, remember, in an ellipse, a squared is larger than b squared. And in this case, a squared is 25, so a is 5. Now, how does that give me the length of the major axis? The major axis is always equal to 2a, which is 2 times 5, 10. Now, b squared is always the smaller number in the denominator. B squared is 9. That means b is 3. That gives me the length of the minor axis, which is 2b. Now, remember the vertices, since this, before I put the vertices on the graph, since the a squared here is under the x squared term, that means this is a horizontal ellipse. That means the major axis is horizontal. So the vertices are a units from the center. So the center is 0, 0. I'm going to count 5 units on each side of the vertex of the center, sorry, to put the vertices. So the vertices are going to be at 5, 0 and negative 5, 0. The co-vertices, we count b units from the center. The co-vertices are vertical in this case because the minor axis is vertical. So we count 3 units up and down from the center. And these are the coordinates of the vertice of the co-vertices, sorry. And we can draw the ellipse, graph the ellipse. We still need to find the foci. The foci are c units away from the center. They're always on the major axis. And we need to remember the equation that relates a, b, and c. So c squared is equal to a squared minus b squared. In this case, c is 4. So from the center of the ellipse, I count 4 units to the left, 4 units to the right, and I play the foci of the ellipse. So this is, again, this is a horizontal ellipse. In other words, the major axis is horizontal because the a squared is under the x squared term. Let's look at the next example. Now notice that under the x squared, I don't have a number, so I can always put a 1 here if I want to. This is the standard form of an ellipse whose center is at 0, 0. So this is centered at the origin. Now, we put the center. Remember, a squared is always bigger than b squared. A squared is always bigger than b squared. Or we can also say a is always bigger than b. Since in this case, a squared is the 36 and it is under the y squared, I can tell now that the ellipse is a vertical ellipse. In other words, the major axis will be vertical. And the major axis length is 2a, which is equal to 2 times 6, 12. So we go from, also, before we put the vertices and the co-vertices, let's find the minor axis. Now, remember, b squared is the smaller denominator. In this case, it's 1. That means b is 1. And the length of the minor axis is 2b, which is 2 times 1, 2. Now, the vertices are a units from the center. and the co-vertices are B units from the center. Since this is a vertical ellipse, in other words, the major axis is vertical, so we're going to go A units up and down, and we put the vertices of the ellipse. So we go up 6 units, down 6 units from the center. The co-vertices are B unit from the center. In this case, the minor axis is horizontal, so we count from the center B units, which is 1 unit to the left, 1 unit to the right, and we plot them on the coordinate system. Now, all you need are the vertices and co-vertices to graph. I still need to find the foci of the ellipse. The foci, to find the foci, there's C units from the center, and you use the equation C squared is equal A squared minus B squared. So C will be root 35. So you're going to go up root 35, which is about 5.9, and you go down negative root 35, or go down root 35, and you put the foci. So again, it's very important when you graph an ellipse, the first thing you want to do, know its center, and you have to remember the equation of the ellipse if it's a horizontal ellipse, and the equation when it's a vertical ellipse. In the next video, we will see 3 examples, or I will go over 3 examples where the ellipse has a center at HK. So we're gonna shift the ellipse horizontally and vertically.